Hello friends, in this lecture we will see adaptive milling, and this adaptive milling is under this mill contour, and this is the second option, adaptive milling. We use this adaptive milling for high speed machining because it increases the tool life and it gives better finishing, and the speed is obviously very high. So with the high speed and feed we can cut any kind of material. So we use this adaptive milling for high speed machining, and we use solid tool for this adaptive milling because the tool is cut with the up to 100% of tool fluid. So in this case I'm going to use a solid tool 8 mm anvil, and my workpiece is this, and I'm going to do this. Okay, and here my depth of cut is up to 90%. Okay, you can also choose as 100%. Okay, 100% of flute length, and still I'm using 95% of tool flute with a step over of 10% of tool die. Okay, or we can enter any value, but in this case my step over is very less, and the depth of cut we can increase up to the 100% of loop length. Okay, so I'm using this parameter, and cut direction, and here depth first, and for open pass we can use this alternate cut method. This is like the zigzag for the open pass, and maintain cut direction is only the jig option. It is like the jig and it is zigzag. So for open passes I'm going to use this zigzag. And from the geometry, by default it selects hold the part, and if you want to specify any trim boundary we can specify. So no problem, just create, then we will specify the trim boundary and feed speed. Okay, and cut level. So here it is 95% of flute length is the depth, and strategy is optimize. No need for this optimization and all, just generate and let's see the result. Okay, we have taken 95% of tool diameter, that's why it is like this. Just see the simulation. Okay, the tool is cutting 95% of flute length. Okay, it is cutting with the 95% of flute length. Okay, and just click OK. Still some material is remaining, so from the main change it to 100%. Okay, and I'm using this continuous adaptive pattern, and we have one helical motion as well, and minimum curvature length we will see in upcoming video. Bottom up cutting between the level, it will also see in next video, we will see this one. Okay, and now from the geometry I want to trim this inner portion. So select face or curve. So this time I'm going to select this curve, and this is the tangential curve. So inside tool will trim inside. Now generate. See, the inner portion is now trim. The tool path is now generated inside this boundary, and Here it is not cutting up to the floor, so I'm going to cut level, and default the bottom range is up to 29. So I'm going to select the bottom of this pocket so that we can define this range, and now generate it again. Okay, and if I want to generate, so I can change it to up to 60% and generate one more time. Now it is cutting 60% of flute length in first level, and same again for the rest of the material will in second level. So let's verify this. Okay, so some material is left here. If we are doing in two level, that time this material will remain here. So this is the adaptive milling, and rest of the option we will see in next lecture.